Okay, we are going to get started once I get some batteries in this thing. Because I don't think it's working right now. Okay, I should be on now. Okay, we're going to get started. Before we do, are there any questions about anything? Okay then, let's continue. So last time we left off talking about vectors, and today we're going to continue on and talk about maps, and then hopefully hit up the other topics that you need to be able to complete your homework assignments. Yes?
Why do we use vectors?
So the question is, why do you use vectors instead of arrays? Is because vectors are a lot easier to work with than arrays. Like the vector will resize itself automatically if you insert something. Whereas if you wanted to insert something into an array, you would be responsible for resizing the object and then putting the element in, moving all the elements over to the right. So it's way easier for you to work with a vector than to work with an array. And if you're ever like, hey, when should I use an array over a vector? The answer is somebody made you. Right? Unless somebody's forcing you to use an array, you should be using a vector in C++. Okay, so maps, what they do is they take a key and they map it over to a value. So with vectors, you can kind of think about this as vectors taken as their key and index, what position into the vector that you want, and they map it over to the element inside there. With a map, you get to specify what you want your keys to be. So they don't have to be integers. They can be pretty much any type that you want. These are pretty much Python's dictionary class, if you're coming from the Python background. The vectors we saw were parameterized over a single type, the type of the element contained inside. Maps are parameterized over 3 types, but normally you'll only ever specify the first 2. The first type is the key type. What do you want to use to index your map? And the second type is the values that's going to be stored inside your map. The third type, if you do give it, is the comparator, which by default, the values in the map will be sorted in ascending order based on less than. So for example, declaring some types of maps, we might have a map that maps strings to integers, and we might call this variable phone book. We might have a map that maps strings to strings. Maybe it's mapping last names to first names. And we might also have another one that maps an integer to a vector of strings, right? So our value type is going to be a vector, which is totally legal. In a map, the keys have to be unique, but the values don't have to be. The keys can be pretty much any type as long as they support an operator less than. This is not 100% true. If you supply a comparison function, you can use any type that you want. I think you could also use the containers as a key if you wanted to, but I'm not sure whenever you would have like a vector as the key. But it would be really weird, but it may or may not be possible. I've never ran into that situation. Yeah. Say it again. Right? If we go back here, they are C++'s dictionary class. So yes, they are. The elements, again, are going to be sorted in ascending order. That means, like, what sorted means is going to be based on that third type, which is the comparison function. So if you did decide to display that, to provide that third type, what that type is going to look like is bool, pointer, const, key type reference, const, key type reference. And then actually the types you wouldn't have here as the A and the B wouldn't show up. What this is a pointer to a function. Come on, go full screen. And basically what this function does is it takes in 2 keys and it returns true if the first element is less than the second element. If A comes before B. I'll make sure to show you an example of actually doing this. If you want to and you get tired of really typing out that long type, you could use something like the using statement to give a type alias for it. Using compare fun equals bool pointer const key type reference const key type reference. You may find this useful for your homework assignment, and again, I'll make sure to show an example. Again, this might be useful to provide if instead of wanting the elements in ascending order, you wanted elements in descending order, from largest to smallest. You can make sure that they were sorted that way. Or maybe if your keys were strings, you could maybe want to have your comparisons be case insensitive, because by default, the comparisons aren't case insensitive. All of the lowercase or all the uppercase elements come before all the lowercase elements. So that might be really annoying if you compared like capital zebra and lowercase apple, and zebra came before apple. But by default, that's what would happen because capital Z comes before little a. Or maybe you wanted your strings to be compared by length instead of by ASCII value. So there are a couple of different types of constructors. You can have, of course, an empty map, a map that maps some values. The values here inside this map are going to be pairs. And when you iterate over the map, what you get out are pairs. A pair is like a two-element tuple, more or less. But if you want to access the first element inside the pair, it's dot first. If you want to access the second element, it's dot second. And we'll definitely make sure to show you an example of iterating over the container. You can also create a copy of another map. You can create a copy over a range. And then there's also, again, you can provide an additional parameter that's not seen here, which would be the comparison function that you wanted to use. So over here, I used the using statement because I didn't want to keep out typing phone book. So phone book is a map of strings to integers. And then I have another function over here, case insensitive compare, that takes in a string reference name 1 and a string reference name 2. And over here, you can imagine that what this function would do, I didn't write it out, but it would compare the two strings, but in a case insensitive way, right? Maybe it makes makes them both all lowercase, and then it compares them to see who comes first. Over here, I use another using statement so that I don't have to keep writing things out. So using compare equals decal type of case, the address of case insensitive compare. This is instead of having to type out bool star const std : string reference const std : string reference. And what decal type does is you give it an expression, and it tells you what the type of that expression is. So it turns out the type of case insensitive compare, if I take its address, is a function to a pointer that returns a bool and accepts two strings as arguments. So we might have our phone book over here. We have a phone book P1. We might decide to put Sally and Bob in it, right? And then again, this would be sorted with Sally coming before Bob because uppercase letters come before lowercase letters. Then I might have a phone book P3 who's a copy of P2. And then I might make a copy of P2 using the iterator method, but instead I'm going to use case insensitive comparison as my comparison function. And so now instead of having Sally then Bob, I'm going to have Bob then Sally. Because if they're compared with that, their case is not mattering, the B comes before the S. You compare the keys. The keys are always what's compared. The values are never compared inside the container or inside a map. Any questions? Okay. So if you want to access an element, again, you can use the square brackets or you can use .at. They do behave slightly differently though. With the square brackets, if the key is not already inside the map, it's not an error. It will be added to the map, and the value that will be mapped to, that key will map to, will be the default value of that type, whatever you construct with the zero argument constructor. With at, though, if that key doesn't show up inside of the container, you're going to get an error. It won't be automatically added. Also, again, you can assign, you can make sure that a key gets assigned some, you map a key to some particular value. Here again, if the value is not, if the key is not inside the map, we're going to add a new element to the vector, not to the vector, to the map, having key now mapped to value. But if you use .at, it's going to replace the mapping. So key already has to show up inside the container. If it doesn't show up inside the container, you're going to get an error. Right? So here's some examples over here. We create a map that maps characters to integers. Right? We have B goes to 3, C goes to 4. If I do m.at_a, right, there's no key who has the value a, so we're going to get an error. But if I do m²a, again, there's no element inside the container, so it's going to do the default value for the character, which is the null character. We're going to get to a second in 1 minute about how to check to see if something isn't in the container already. So now if I do m.at_a, since it was added into my map, this is not going to have, again, a maps nothing. If I do m at b, we get 3. m.at_b, we get 3 as well, because they're both inside there. If we do m.at_c = 5, we're now going to make c map to 5. If I do m.b = 10, b is now going to map to 10. If I do m.at_d = 35, that's an error because d doesn't show up in there. But I could do m.d = 35, and then that's going to be fine. So my question to you is, when should you prefer to use .at, and when should you prefer to use the square bracket? Yeah. Yeah, you should use .at when you want to be guaranteed that that thing has to be in the map, right? And if it's not in the map, you want that error to be reported. Right? You would use the square bracket if you didn't care if it was in there, and if it wasn't in there, you wanted it to be added. Does that make sense? So if you want to add or remove elements, you can do your map.insert, and then you have to specify a pair that maps the key type to the value type. You can also use the square bracket operator to add that element in there as well. Perfectly fine. You can do m.erase some iterator position to remove the element at whatever that iterator is currently at. Again, once you erase something using the iterator, or you remove any elements at all in any way, any iterators you have over your object are no longer valid. This holds for all containers. You can also just provide a key, and you'll erase that key value pair. And then again, you can provide a range of values to erase using some iterator pair. Erase everything from start up to, but not including end. So here we have m, and we insert into it 3, 5, missing a curly bracket there. We could also do m.insert some pair of int. This is the pair where 1 to 100. And then we could also do make pair to make a pair, 5, 50. So if you just wanted like a standalone pair object and you didn't want to do anything, like you just wanted a pair, you could create a pair by doing std::pair, and then you list the type of the first element, type of the second element, or you could use make pair to create a pair. So the type of that pair is std::pair, first element type, comma, second element type. We could erase 5, so this would erase the pair 5 to 50. We could erase the first thing in our container, or we could erase everything in the container from the beginning up to, but not including the end. Any questions here? Yeah. So 3, 5 is also a pair, and this would be inserting it with like the initializer list construction of a pair. So normally if I'm going to be doing this, I would do it the first way. Sometimes, though, it won't allow me to do this for whatever reason, and so the other two versions over here are guaranteed to always work. So if you want to, yeah.
Use
So we will eventually get to namespaces and what they mean and why we use them later on, but the main reason is to prevent name conflicts. So there is a good reason for me not saying using namespace std, We'll talk about it when we get to namespaces, which hopefully might be at the end of this week. So if you want to check to see if an element exists inside of the map, you can use .count. Since the keys have to be unique, the count can either be 0 or 1. So if it's not in there, the count will be 0. If it is in there, the count will be greater than 0, which means it has to be exactly equal to 1. If you had a multi-map, though, it's possible for the count to be larger than 1 because the same key can now map to multiple values. So if we had a map that maps again ints to ints, and so we had two elements, 3, 4, and 4, 8 in there. So if I count 3, again, we're checking on keys. Oh, there's one guy who has a key who has count 3. So we'd get 1. If we did m.count4, we're also going to get 1. And we're talking about the second element because his key is 1, not his value. We don't care about values when we're doing the lookup. And then m.count8, well, there's nobody who has a key of 8 in there, right? Because the first element is 8, so count would be 0. That element's not in the container. Questions? So we'll do some examples. One thing that we haven't talked about yet are sets, but sets are essentially maps where the key and the value are the exact same thing. So if that statement made sense to you, you understand exactly how sets work, right? They're sets. Sets are maps where the key and the value are the exact same thing. Same type, same value. Oh, oops. So again, your .h files, what do you put in your .h files? Put declarations, right? So I'm going to put a couple of declarations here to make my life a little bit easier. So over here, I'm going to pound include map because we're planning on using that. But I'm going to say using, again, we're going to call it a phone book is equal to an std : map that maps strings to integers. That's my type right there, right? I'm also going to be using comp is equal to bool star const std : string reference const std : string reference. So again, the function that we're going to be using to compare, it's supposed to return a bool and take 2 strings as arguments, right? And it will return true if the first string comes before the second string. Does that make sense? Right? And over here, what we might do is now our phone book is going to use the comparison function of this type to do the comparison. So instead of using the less than operator. So over here, we might have something, maybe have like void add contact. And what we do is we take in our phone book, and we'll take in a reference to the phone book. And we'll take in a const std : string reference name and a integer number. So what we want this function to do, is we want this function to add this contact to our phone book. Does that make sense? So what function could we use to do that, to add them in? We could either use the brackets or we could use insert. So if we wanted to use the brackets, right, it would just be phone book at name is equal to number, right? If we wanted to do an insert, phone book dot insert name number, right? Either one of these would work. Any questions here? Yeah. Can you say that a little bit louder? Oh, so why am I accepting a reference to the phone book? Because I have to have somebody, I have to have some, phone book to add this person to, right? And notice I'm taking a reference, so it allows me to modify the original. Another option which you could have done, but probably wouldn't be what you'd want to do, is you could make a copy of the original phone book, add the new person into that new phone book, and then return that new phone book that had all the originals plus the new one, but it wouldn't modify the original one. Probably not as good, probably not what's intended, but it could work. Just be a lot more expensive to implement. Yeah. Yeah, I'll show you in like a minute about like what it's going to do, but we're going to use it to do our comparisons between the elements, because we probably want the comparisons to be case insensitive, so that when you listed your contacts out, right, you got it as an alphabetical order, and independent of whether you entered their name in lowercase or uppercase. The comparison will be done during insertion as to where to put the element in. The insertion is not constant time. So I think we mentioned this when we first started talking about the containers, but set and map also have unordered versions. So there's an unordered set and an unordered map. So with an unordered map, the insertion time is more or less constant, right? But iterating through that map is more expensive. It's not constant time. So pretty much you have a choice between like whether you want to use unordered or ordered map. And you have to ask yourself, what am I doing more of? If you're doing a lot of iterations through the container, use the ordered version, it'll go faster, right? If you're doing a lot of insertions and deletions, those are your primary operations on it, use an unordered map. So the next thing we might want to do is like void, print contacts, and we take in a const phone book reference, and it's called phone book. And so now we want to print out our contacts. How could we do this? We're going to need to include IOStream for that to happen. So again, I need to go through each one of my contacts, right? So I need to use a for loop. Which type of for loop should I use? Index for loop, iterator-based for loop, or element-based for loop? Element-based for loops. Of those three, there's actually one you can't use. Which one can't you use? You can use the iterator one. You can't use the indexed, right? Because there is no index 0, index 1, index 2, right? Because the way that you look up the elements is not by their position, it's by the key. There is no element 0 inside here. So you'd either have to use a element-based for loop or an iterator-based for loop. I'll use the element one. So for const auto reference name and number in the phone book. So what you might be able to do over here is const auto reference, say like name is equal to name and number dot first. So if you want the first element in the key value pair, it's first, and the first element is the key. The second element is the value. Because when you iterate through the phone book, you're going to get back out a pair. So if I want to make this type over here explicit instead of auto, it's an std : pair of std : string to integer. That's the type. So you get a pair. I like using auto here because I don't like writing that type out. And the type of the loop variable is different from the one returned by the iterator. You want const here? It's a const string. So once a key is inside of the map, the key's not allowed to change. And then so over here we might do like std : cout. And we might say something like sound good? And then finally, what we're going to do over here is we're going to make one more function. Case insensitive less than. And it's going to take a const std : string reference string 1 and a const std : string reference string 2. So why do I make my variables const here? I'm not planning on changing them. Why do I have references? Because I don't want to make a coffee, right? So how could we do a case insensitive less than? We could do them all into lowercase, right? And if you remember, we kind of did that earlier in one of our previous examples. So what are the nice things about splitting up our code into multiple files is the files where we're doing the case insensitive comparing, we can just copy them over to here. There we go. So here's more string functions. So what we can do is the more string functions.h and the more string functions.cpp, we can just copy them into this project. Say thank you for copying it, but now we can't use, we have to add them to our CMake lists. So we'll add in more string functions.cpp and more string functions.h. Reload our changes. Load them again for whatever reason. And then in the more string functions, we're not going to include char functions anymore. We're going to include the more appropriate C type, CC type. And so now over here in my function, I can include more string functions.h. And for my case insensitive one, I can have an std : string lower 1, which is, what do we call our function? Just call it lower 1, and we can have a lower 2, who is, or I guess probably this is even just better written as return lower string 1 less than lower string 2. Right? I don't have to rewrite my code because it was in a separate file, or copy and paste that code directly into my files over here. I can just reuse those files that I wrote, which is a big advantage of splitting up your code. Any questions here? Yeah. Say it again? Yeah. We're going to get to that in 1 second. But any questions here? Okay. So now we'll pop back here over to main, and we're going to include phone book. Oops, not inside angled brackets, but inside question marks. And so here I might have a phone book called pbook. And again, so for his types, we might start him out as having some values. So maybe we have something like, Matt goes to 1, 2, 3. And any more curly brackets here? These ones need to actually be curly brackets. And then, maybe we have another person, Bob, who's at 5, 6, 7. And then over here, can I do the initializer list? I should be able to. Then I should be able to, over here, say my final element is case insensitive less than. No. Okay. That works. And then we might do something like ebook dot, oops, we might call it just like add contact pbook. And again, we might have like Matt 3, add contact pbook. Maybe it's like Zelda 5, 6, 7, and then add contact to the phone book. Okay, so we built. And so when things get printed out, right? Oops, that looks a little bit nasty. Space there. So when you look down here, right, notice it did it in alphabetical order, like Apple, then Matt, then Zelda, right? If I take out the fact that I want to do I guess I would have to remove this. Get rid of that. And then over here, phonebook.h, comment this out. Oh, something's got messed. Okay. And now if we go and we do it again, notice it's not case insensitive anymore, right? Because if we look at the ASCII values, right, it's comparing the ASCII values of the characters, and you can see, right, that little a, 97, right, comes after both big M, 77, and big Z, 90. Do you guys have any questions about using the maps? Yeah. There would not be, so the only way to sort it by phone number would be to make the phone number the key, right? So one thing that you might need to do is like you'd have to make a completely different map where the keys were the numbers and the names were the values, right? Does that make sense? Are there any more questions about maps? Yeah. The keys, yes, are immutable. You can't change the keys. You can obviously like remove the key value pair or add new key value pairs to the map, but the values are still mutable unless you said they weren't. Any other questions? Do you have any things that you'd want to do with maps that I haven't showed you? Yeah. So a multi-map is a map where there can be more than one of the same key. So like with a like right now with our phone book, if we go back here, right now with our phone book, we couldn't have two people with the same name. So if we happen to have two people that had the exact same name, they wouldn't be allowed to be in our map, right? But what you can do instead is you have two options. Option number one would be to use a multi-map, because then you can have two of the same key value pairs, right? The other option that you could do is you could have just still a map, but the phone number, instead of mapping from string to int, could map from string to vector of integers, right? But even then you would still be able to list out those different people's numbers that happen to have the exact same name. The type of a multi-map is multi-map. So with a multi-map, the keys, like a duplicate key, can show up any number of times. It can be 0, 1, 2, 3, 4, 5, 6, whatever number you want it to. Yes? Oh, the way that it linked to the Boolean function, right, was back here in main. When I declared my phone book, I said I wanted to use case insensitive compare. And then back here in phonebook.h, I would need to remove the comments from over here. Right, so when I constructed my map, or when I constructed my phone book back here, I passed in the function that I wanted to use as the comparison value. So your question is, what does the asterisk here mean? It's syntax, and it means that the type of compare is a pointer to a function, which we'll talk about pointers later. If we're really lucky and things go amazing this quarter, we'll have time to talk about function pointers, but unlikely. So just know that this is the type that you would have to use if you wanted to specify a different comparison function than the default one. Are there any other questions? Okay, then we will move on from containers. We may cycle back here a little bit later this week if we have time. So we'll talk about some easy things, which are pretty fast. First thing is command line arguments. So command line arguments are another way of passing values to a function or passing values to a program. You pass these values when you start the program, whereas the other way of getting values is from the standard input, like cin, reading it as the program's running. You've actually seen this before with a lot of the commands that we talked about, like on the system, like ls, cd, move, copy, right? You say ls/bin, cd ... copy file 1 to file 2, right? It's not like you're like ls and else is like, hey, can you tell me which file you want to see the contents of? And you're like, oh, /bin, and then it runs and prints it out, right? You specify what directory you'd like to display the contents of as you're specifying the name of the program to run. So if you want your program to be able to accept command line arguments, you have to change your signature from int main, no arguments, to int main, int argc, char ** argv. Argc is the count of the command line arguments, so how many command line arguments did you receive? And argv is actually the command line arguments, and it's an array of strings. You don't have to name them argc and argv. That's just their traditional names. They can be whatever you want. If you wanted to call argc Bob and argv Sally, it's going to work. But the types have to be the same. The reason that we use an array of strings for our types here is that strings could be used to represent anything. And in general, in the general case, we don't know like what all functions should accept as their types. But a string could represent any of the types. argv0 is going to be the name of the program. So be careful with that. So it means that the real arguments actually start at argv1. It also means that argc will always be at least 1 because you always get the name of the program. If you want to pass command line arguments to a program, after you type the program's name, just enter them in and make sure that each one is separated by a space. If you happen to have an argument that does have white space inside of it for whatever reason, enclose that argument inside double quotes. And that will make it be treated as one thing. So you can have like hello you, this would be interpreted as a single argument because it's in quotes. Or goodbye me, again, also a single argument because it's inside quotes. You could enclose things that don't have white space with quotation marks, but that's just extra work, and most of us don't like doing that. But it works. If you're in CLion and you want to specify command line arguments, you go to Run, Edit Configurations, then you enter the arguments in the Program Arguments area. So if you want to convert elements from strings to something else, right, because you might want to be receiving numbers, right, and they always are supposed to be numbers, you can use some of the conversion functions. Don't try casting, it won't work. Don't try doing something like star argv1. Star argv1 is the first character of that string. So if the user entered in something like 123, you would get character 1. And character 1 doesn't even have like a numeric value 1. Character 1 is like 42. So be careful with that. You can see that if you got character 1, right, it's actually, I guess, 49, since it's numeric value. So the functions that you would use to convert would be a string to integer, if you were trying to convert a string to an integer, or string to double, if you wanted to convert that string to a double. If you're trying to go the other direction, right, like from an integer to its string representation, the method is toString. All these methods are defined in string, so include string if you want to be able to use them. That's it with command line arguments. Any questions? They're the values that you specify when you run the program. For example, back here when you did something like ls/bin, /bin is a command line argument, right? Because you specified that value as you specified the program to run. Or file 1 and file 2 after you did copy, those would also be command line arguments. Yeah, we're going to get to that right now. So here's a simple example, and all it does is it prints out the command line arguments. So again, I start I as 0, I less than argc plus I, and I just say, argv at I equals whatever it happens to be. So if we go to like Run and Edit Configurations, over here in Program Arguments, this is where you would specify your command line values. And every time you press play, these are the values that are going to be used. If you want to use something different, change them. So if I press play, you should see those values all get printed to the screen. But notice argv0, it's the name of my program. So, which is a very, very long name, because it's giving the full path to it. But argv1 was hello, argv2 was bye, argv3 was y, and so on. But remember, these are all the string representations. So it's really not the number 23.45, it's the string 2, 3, period, 4, 5. If we wanted to use it as the numeric value, we'd have to do the conversion. This guy right here is just showing you that if we put quotation marks around our argument that has spaces in it, it's treated as one argument. This is really important for you guys when you're specifying your paths to your files, because if your path happens to have the space in it, right, like you have like homework space 1 / test file, that would have to be enclosed in quotation marks, because otherwise it's going to see it as two different arguments, homework and 1 / test example, not the full path of the file. And so you would fail to open the file at that point. Any questions here? Okay. This program, what it does is it takes in a set of command line arguments that are supposed to represent integers, converts them to their numeric values, and then adds them all together. So what I do is I go through each of the arguments, but notice I start at 1, because argv0 is the name of the program, and I don't want to try adding the name of my program to my sum. It's not going to make sense. So I go through each one and I print out its value. Then if it's not the last one, I also print out a plus sign so it looks nice. And then I convert argv at I to its numeric value and add it to my total. And then I finally print out, the total is equal to whatever. The values that I have over here right now to test with are 5, 5, 10, and 13. So we'd expect our sum to be 23 at the end. So I'd expect to see 5 plus 5 plus 10 plus 3 is 23. So 5 plus 5 plus 10 plus 3 is 23. Any questions on command line arguments? Hopefully that seems like a very simple concept in comparison to everything else that we've been doing. Okay. So let's talk about files real quickly. Also, again, if you're feeling overwhelmed or you're having a lot of difficulties, stop by office hours. I'm more than happy to talk with you about what we're doing in the class and clarify any confusions you have. So if you want to use files, you have to include fstream. There are 3 types of files defined inside fstream: an IF stream, an OF stream, and an F stream. IF streams are for reading, OF streams are for writing, F streams are for allow you to do both, reading and writing. One thing that's really important is make sure to only use the appropriate type of file stream for the operations that you want to do. If you're only planning on reading, use an IF stream. If you're only planning on writing, use an OF stream. Not only does this make your programs more secure because you're not asking for permissions that you don't need, you might also run into issues when you're doing your homework. Because the files that I have you test with, if you're reading the file in, those files are all read-only files so that you guys don't mess with them, right? Not one bad student goes and destroys the files. So if you tried to open the file using an F stream, it's going to fail on Codathon because F stream is trying to open it with both read and write permissions, but the files only give you read permissions, right? So it would totally fail and it wouldn't work. But on your computer, right, you probably are allowed to both read and write that file. So it would work on your computer, fail when you submit it, and you might be like, why does this not work? And it's because you don't have permissions to open the files on Codathon, but you would on your computer. So for your homework, use IF stream. We will continue our discussion on Wednesday.